Screen, and then we can hide this and pull this back. Boom. Okay. Uh, yeah, that's fine for now. So yeah, that was a game called Nonogram. Is there no other way? Yeah. So as far as Pearson for right now, let's see, Mr. Bell. I think we got you, Mr. Bell. Yeah, you're good. Um, yeah. So for Pearson, so I asked around. I just kept asking around. It sounds like again, Morehouse is not a part of the Include Ed program anymore. So we do have to purchase our materials. Now I know I had at least one student that successfully purchased a paperback version of the book from the bookstore, and it was a new copy, and it came with the My Math Lab access code. So when you purchase your book from the bookstore, just make sure it's a new version, and make sure it comes with the My Math Lab access code. That because that's how we're doing all of our work is in My Math Lab. Okay. Or you can actually just go directly to My Math Lab and purchase full access there. So like log into our class, and the options should pop up. So now I have that we go until about 6:30, which is about an hour out. Let's take some time. Let's take some time to see Mr. Jones. Okay, let me see. Let me make sure you got your attendance credit. I'm gonna hide this. Hop over.
I got a question.
Hang tight, hang tight.
Um,
Jalen Jones, I see you in the chat. I know you're here. Did I miss anybody else? Anybody else come in late? Did not get attendance credit for today? Anybody else? Going once, going twice? Okay. Let me. I just gonna hop over here like this. And then now we can bring this back. Awesome. That's okay. Okay, there was a question. Go ahead.
yes, sir. Did you ever answer Zaire question?
About which one?
I'm not sure. It was about the full trial because I ordered the book and it's coming in on the 10th.
So yeah, as long as you have temporary, I know the temporary trial is going to expire soon. You just have to hang tight. If you order the book new from the bookstore, it should come with the My Math Lab access code. I know I had at least one student order the book new from the bookstore, and it did successfully come with the access code. So that's where we are. So you can either order it again if you order it new from the bookstore. Again, just make sure to the best of your ability that it comes with the My Math Lab access code, or you can purchase an access code directly from My Math Lab. They're both the same.
Well, I ordered mine off Amazon. So
did you order it new or used?
No, I ordered it new.
Yeah, so if it's new, again, even if you order from Amazon, just try to make sure, that it comes with the My Math Lab access code.
Okay.
Yeah.
So, because my trial ends in 3 days.
Yeah, just do the best you can.
All right.
We'll have a workaround if your materials haven't arrived yet.
All right, then. I'll just try to get 3.3 done or something like
that. Yeah. We're a little bit flexible. Let me see. Gives you the access code depending on how long you want it. Okay, so it sounds like they have options if you buy from the Morehouse bookstore. Again, you just want to be sure to get the full access. Okay, so now from here going forward, if we have questions, just write them down or type them in the chat, and I'll try to pause. Like if I see it in the chat, I'll try to pause and address it there. Let me see. Let me go to everyone. So yeah. I can't think of any other announcements. The main thing is that as long as we're making our way through Pearson and getting those assignments submitted, that's the main thing. So this week we're just focusing on section 1.3. We get unlimited attempts at all assignments, and if we submit assignments late, there's only a 10% late penalty. So honestly, if you really want an A on any assignment, even if you submit it late, you can get it. I've had students do that. They submitted everything late, but they maxed out all their scores. I noticed it, so I factored it in into the final grade, right? So honestly, I mean, whatever grade you want with grit, you can get it. It's possible, okay? Okay, so we're going to pick up where we left off. So let me see. If I click here, are you bugging? You are bugging. Okay, let me do like this. I don't need that either. And let me just reopen it, because I usually will fix it. Okay, this is looking good. This is the 515. All right, cross our fingers. Awesome sauce. That's looking good. Okay. So the last thing we talked about, we had functions, and we were basically evaluating functions. So we were replacing the x's and plugging things in for x, right? That's where we left off last time. So on Monday, that's where we stopped. So we're just gonna pick up here, and I really don't want. I want to do about 15 slides a day. So when we hit about slide number 30, that's about as far as we need to make it to today. Right now we're at 20, so it's not really that. It's not too many. We don't have to. We don't have to rush. Okay. So here we asked to find the domain of each. Okay. So let me actually get a copy of this. I don't need this. Let me see if I'm streaming. I can't tell. I am streaming. Okay. I can hide this actually. Oops, clicked on the wrong thing. I want to hide this, yes, and bring this back. Just wanted to make sure. And let me check. I should have a notification. Yeah, the 5 p.m. Yeah, okay, we're good to go. And then this, I wanted to copy here, here, like this, okay? Then I want to take that, actually, let me share, and I want to copy that. Oh, this, I'm really geeking about the behavior of this. It's like, it's doing so awesome, so well. Add a page. Because like all the little edits that I'm doing, it's like, because it's in presentation mode, you can't see all of my edits, which is, it really helps out a lot. Like I'm really grateful of these updates. I can always get so much better with each update. I'm so excited. And then let's do, actually we want to change the view to seamless. Okay. All right, so let's give this a go. So we're asked to find the domain of each of these. Hey Google, turn the fan off.
All right, turning off fan.
Yeah, we are having class every scheduled period. Only day we get off is Wednesday. We even meet this upcoming Monday, which is Labor Day. So we're gonna be here. We don't get any breaks, but on the flip side, we actually end the semester much earlier. We're gonna be done before Thanksgiving. So we're gonna be done. Oh, Google, I'm a technology whisperer. I consider myself a technology whisperer. You can actually link Google to do nearly anything. I have like E ports or E switches, and so it's like the fan is always on, but the switch controls the power. So then once you link the E switch to the Google device, and the fan is always on, you can control the power to the fan with the Google. You can do TVs. I can do the alarm system, cameras.
That's tough.
Like you can do so many things. You can like almost anything that comes to your mind. There's a way to control it with these devices. That's a good thing and a bad thing, because like the bad thing is, one, the thing is listening. You know, so if you kind of like any kind of paranoid like I am or anything, I know it's listening, but I ain't got nothing to hide. You know, so you know I'll be okay. If you don't mind it listening to you, then that's one thing. But if you're doing something nefarious, I wouldn't even have it nearby, because who knows if it runs on battery? Who knows? You know, just because we turn it off, we don't know if it's truly powered down. You know, so I don't try to get into all of that, but yeah, but you can do nearly anything that comes to your mind. Control anything, nearly anything that comes to your mind with these devices. So it's a blessing and a curse depending on how you work it. So with this, we're asked to find a domain, right? Let's open up some graph paper like this. So in general, for a rational function, so if we're looking at part A here, in general, for a rational equation, we cannot divide by what number? We cannot divide by, so when we have fractions, what number can we not have in the denominator? We cannot divide by the number 0, right? So we want to throw out any x that makes the denominator 0. So what we're going to do, we're going to set the denominator equal to 0 and solve. All right? If we set it equal to 0 and solve, if we add the x squared on both sides, we get this. Take the square root. Ultimately, we get x equals plus or minus 1. So whenever we do square root, we have to introduce the symbol plus or minus. All right? So this is saying if x is positive 1 or negative 1, it'll make a 0 in the denominator. So the domain there is going to be everything except those two numbers. So the far left would be negative infinity up to negative 1. And then we're going to go from negative 1 to 1. Give me a moment. And then we're going to go from 1 to infinity. I'm going to rearrange this. I just kind of ran out of space, so I'm going to do this. Shrink this down. and I want to position this like here, and I want to position this here, and then I want to take this, and basically I want to position it here. Maybe here. So that's about the size I'm comfortable, right? So in this form, we're saying that basically, again, x cannot be equal to plus or minus 1 because they make a 0 in the denominator. So we had to throw out the plus or minus 1. So in this interval form, we're saying all real numbers work except plus or minus 1. Can somebody explain to me the difference between parentheses versus square brackets? What's the difference between parentheses versus square brackets?
This is Miles. Parentheses is like, I know square bracket is when it's like it doesn't go beyond that domain. It doesn't go beyond that number.
What about parentheses?
It goes beyond that number.
That's not what it is, right? So parentheses mean we get really, really close to that number, but we do not include that number. Brackets means we get really, really close to that number, and we do include that number. It's okay. I finally figured out what those emojis mean, like the tears. It's like, it's okay. But see, so don't feel bad about making a mistake. Like that's human nature. That is our design. We're designed, like, I feel like as humans, we be stressed out because we be trying to get outside of our nature. We try to be perfect. We try not to make mistakes. And that's okay, but our natural design, we're designed for trial and error. We're not robots. We're not designed to get things exactly right on the first go. We're designed to do something and we get feedback. And so we really only truly fail when we quit or we give up. But as long as we have breath in our body, we never really truly fail. Okay? So don't feel too bad about it. But the whole point of this experience is we're in the lab. It's to make trial and error, to explore and experiment. And then to say, okay, when I do this, what happened? Oh, okay, that was right. Okay, wait, this time I did it, it didn't work. What's going on? And so that's the whole purpose of this interaction that we're having. So, you don't have to feel bad about, quote unquote, getting something wrong. I was speaking on something else, and I totally lost my train of thought. Turn on date night lights. Uh-oh. Is there a group for me? Is someone can group me? I think there might be a group me, so I think there was a request for it. Keep in mind, I am streaming live on YouTube, so I don't know how you all want to work that. I just want you to be aware. I'm going to try your Google command. Let me see. Hey, Google, turn on date night lights.
Turn the red lights on.
Okay. So, but Google can't do it. Watch. Okay, so, hey, Google, change the light color to red.
Demon time. Demon time. It's demon time.
So it's time for an exam. Hey, Google, change the light color to white. But yeah, I forgot about the lights. Yeah, you can do so many different things. I have the lights program, the alarm system, cameras, TV, fan. And I feel like if my stuff would ever get hacked, I don't care about none of that stuff. So I'll just dump it and move on. Okay, so let's move on to part B. There was something, but we'll come back to it. All right. So in part B, the domain we have is g of x equals the square root of x. Right? So we cannot take the square root of what kind of numbers? Right? What kind of numbers can we not take the square root of? Negative, right? So if we can't take the square root of negatives, that radicand needs to be non-negative. So in other words, again, this radicand here needs to be non-negative. So that means x needs to be greater than or equal to 0. What's the difference between positive versus non-negative? What's the difference between positive versus non-negative? I'm going to just let that... Pardon?
Includes 0.
Yeah, that's exactly what it is. Positive is strictly larger than 0. Non-negative is strictly larger than 0, and it includes 0. Do you see the subtlety, the subtle difference? Mathematics is all about precision. It's about pattern recognition and like being precise with our concepts and our words, right? So positive is one notion, and non-negative is the exact same thing. It's just the other one includes 0. And those subtle differences in that one number, it has several applications, and it has like it's very nuanced, but it has its place. I noticed that the precision of mathematics and that energy of pattern recognition, to me, like when I'm gaming, it's pure math. Because when you game, it's all about pattern recognition, but it's about pattern recognition of your opponent. Sometimes I psych them out, sometimes I fake them out, sometimes I'll juke them, sometimes I'll bait them. It's all about, and sometimes I'll lull them into a rhythm. I'll choose this dopey character. His name is Diggy, and I'll be like, just running around, very unassuming. He's totally weak, but I'll be like getting into their minds, and I'll be pissing them off intentionally. Sometimes they piss me off. And so it's all a mind game when you're going live. But that's mathematics. Mathematics is all about pattern recognition. So then once I lull them into a rhythm, then I'll just sit there. But they don't know that my partner's waiting in the bush. They can't see my partner in the bushes. So then when they chasing me and they dump all this stuff on me, and it takes about 3 of them to take this guy out. Then once they've wasted all their stuff, now they're sitting ducks, and my team could just wipe them out. It'd be so much fun when that happens. But that's mathematics. It's pattern recognition. Attention to detail, this kind of thing, and then just putting our own spin or mix of the human flair on it. So again, for B, we can't take the square root of negative numbers, so our number needs to be non-negative. So our radicand needs to be greater than or equal to 0. And in interval notation, we're going from 0 to positive infinity. What kind of grouping symbol does a 0 get in this case? Does it get a parentheses or a square bracket? Parentheses or a square bracket. So right here, we are focused on
Square bracket.
Why did you say square bracket over parentheses?
Because it's less than or greater than or equal to.
Because of the bar, right? Because it is equal to. So because it can be equal to, we're going to use a square bracket. So again, parentheses mean we get really, really close to that thing, but we do not include that number. Square bracket means we get really, really close to that thing, and we do include that number. And again, because of this bar here, that's why we did a square bracket. Okay. What symbol does infinity always get?
Parentheses.
Parentheses, right? Infinity always gets parentheses. Okay. So this was our solution for part A. Okay. We're gonna go like this. Style like this, right? And then for part B, we got this. Okay. And let's go like this. Okay, that's looking good. Let's move on to part C. All right, so we want to find the domain of that function. So if we're looking at part C, let's just zoom in because we can. So again, we have to impose, it has double stipulations going on. We can't take the square root of a negative, so normally we would need that radicand, which is x minus 1. Normally that would need to be greater than or equal to 0. But because the radical is in the denominator, it can't be equal to 0 because we can't divide by 0, so we got to remove that bar. So now we have to impose an additional stipulation that the radicand has to be strictly greater than 0. Does that make sense? We can't take the square root of negatives, so it has to be non-negative. But also we can't divide by 0, so also it cannot be equal to 0. So then we finish with something like this. And if we solve, we add 1 to both sides. We get x is strictly greater than 1. So then we're talking about the numbers 1 to infinity. Again, infinity always gets a parentheses. In this case, the 1 gets a parentheses. Okay. Style and like this, okay? And then, so for D, again, we cannot take the square root of negatives, so I need a little bit more space. I'm going to start here with D. So that radicand being this x squared plus 2x minus 3, that needs to be greater than or equal to 0. So again, as we kind of work through these examples, you can actually type your questions into the chat. I am monitoring the chat. Or you can stop me. I think we got a little bit of time, so you guys can stop me if anything isn't clear. So now with this, we have a quadratic inequality, quadratic inequality. So first we just solve the quadratic like normal as if it were an equation. So first we would factor, right? We want to factor it into something of this form. We have x and x. We got a plus and a minus, positive 3 and a negative 1. Okay? So from here, if this is the positive x in that direction. So the solutions that we get are -3 and +1. So here's -3, here's +1. If we look at the original, notice that the highest exponent is a 2. Can anybody tell me what kind of graph can we anticipate if the highest exponent is a 2? What kind of shape is it? It's going to be a parabola, which is a U-shaped graph. What does this -3 tell us about the graph?
That's the intercept.
Which intercept?
The y.
Okay, so we're expecting a U-shaped graph. It has a y-intercept of -3. Notice that the leading coefficient is positive. So what does this tell us about the graph?
It's going to open.
It's going to open upwards, right? A U-shaped graph, y-intercept of -3, and it opens up. So we're anticipating something like this, right? So then our claim is that the -3 and the 1, those are going to be our zeros on the x-axis. And then if we have a U-shaped graph, we're kind of anticipating. Now you can confirm this by choosing x's, find the corresponding y's. We would anticipate a graph that behaves in this nature. So like if we chose a number to the left of -3, we would anticipate the result to be above the x-axis. If we choose a number between -3 and 1, and it's probably a good idea to verify that these are actually the case. So like, you notice if you plug 0 into the original, you do get a negative. If you choose a number to the right of 1, namely if you choose 2, we're anticipating a positive result. Let's see, 4 plus 4. 4 plus 4 is 8, minus 3 is 5, is positive, right? So all the numbers to the right of 1 are going to be above the x-axis. So then this is saying, when is this quadratic above the x-axis? We see on the extremes. On the left of -3 and on the right of 1 is going to be above the x-axis. So then the final result, the domain is going to go from the far left is -infinity up to -3, and then from 1 to infinity. Not like that infinity symbol. Try my infinity symbol one more time. Infinity, that's a little bit better, and that's not going to work for me. I'm going to copy this. I'm just totally being a little bit OCD right now. Let's copy and paste. Boom. Okay. Infinity always gets what symbol? No, part C does not have a greater than or equal to. If we're just doing the radical by itself, it would be greater than or equal to. But then in part C, the radical was in the denominator, so we could not be equal to 0, so we had to remove the equal to. But we have the equal to because we can take the square root of a negative. Infinity always gets a parentheses. Okay? Because we can be equal to 0, should the 3 and the 1, should they get a parentheses or a square bracket? Because we can be equal to 0, should the 3 and the 1, should they get a parentheses or should they get a square bracket?
Parentheses.
Oh. So they should get square bracket, remember, because they can be equal to 0, right? Because of the bar. The bar right here, this bar means bracket. This bar means bracket.
Oh, okay, yeah.
Okay. So we can do a bracket, and we're going to combine it with a U. I don't think she's cooking anything. All of a sudden, it smelled like Cajun food. It smelled like so delicious out of nowhere. And I don't think anybody's upstairs cooking. I don't know. Maybe somebody's cooking something. Okay, so we got this. And it totally got me hungry now. I'm like, now I can't stop thinking of like red beans and rice and stuff like that. Like, I think I know exactly what that was referring to. I have a friend that's from New Orleans. I need to check on her. What is going on? Why are you behaving right? There we go. We want this. Okay. And let me do this really quickly. Okay, let me pause. Anybody want to ask any questions? So I know the pace might be a little bit quick. That may have been a little bit information overload. Hopefully going through the homework with the Pearson and the viewing example and the explanations, hopefully that's enough. Between our interaction, working with your classmates, linking up with the tutors, hopefully one of those sources, something's going to click. So we got these results. Let me see. So for A, you see it there. Let me switch my view back. single page. So for A, we see that result there. That's what we got. For B, 0 to infinity, I think we got the square bracket. We're okay there. For C, we said 1 to infinity with parentheses. We definitely did that there. And then for D, I think we got our square brackets, okay? I'm going to let those ride. Let me see. We don't have that many more slides that we need to do. Okay. So this example says let f of x equal x squared with this domain. Let me see. Do I have a space? So is 10 in the range? Okay, I like to work this one. Actually, I'm going to give myself some space. I feel like it's just easier to see when you have more space. Okay, I'm going to go like this and like this. Here. Come on. Here. And I want to copy this. Copy. I want to add a page. I think we are here. Add a page. Let me open this back up. Now we can drop it where we want. That looks good. Okay. All right. So, oh, and let's switch it back to seamless view. Okay. So we have this example. Let f of x be this with this domain, and we're asked, is 10 in the range of f? I'm just going to work this one a way that I've seen it done in another text. So we have A, right? If that's the domain, so the original is f of x equals x squared, and we're restricting the domain to 3 to 5, inclusive. Let me make that x a little bit more clear. So then I'm just going to plug in the endpoints. So then, like for instance, if we do f of 3, 3 squared is going to be 9. And then if we do f of 5, 5 squared is going to be 25. So my claim is that the range is going to go from 9 to 25. Okay. So then notice that 10 is in that, so I would say yes to the first one because 10 is between 9 and 25. And then for B, is 4 in the range? Notice that 4 is not between 9 and 25, so I would say a no there. And then we see the range actually listed out there already for part C. So I think the text does it a little bit different. A little style. Okay, so the text, let's switch this back. Let me see. So they said, okay, let f of x equal to 10. If we let f of x equal to 10 and f of x is equal to x squared, so we have x squared equals 10, take a square root on both sides, x is going to be plus or minus the square root of 10. The negative square root of 10 was not in that domain, but the positive square root is between 3 and 5. So because the positive square root is between 3 and 5, then that means that 10 is in the range, right? So 10 is in the range. So that's the way the book does it. They set it equal to 10, and then they work it that way. And then for the next one, they set it equal to 4. If we set the function equal to 4 and solve, take the square root, we get plus or minus 2. Notice that notice that plus or minus 2, neither of those are between 3 and 5. So that means that 4 is not in the range of f. And then find the range. X equal to the square root of y. So I think if we take the original and solve for x, yeah, I'm just going to stand with the way I did it earlier. I don't understand the explanation. It's a little bit, I got to think about the way they're explaining it. But one of the ways I've seen it articulated was basically plugging the endpoints. Now, there's more to that story, but for our purposes for right now, just plugging in the endpoints for something like that should work. Okay. All right. I don't see any questions in the chat, and we have about 30 minutes. Is this where we stopped earlier? $45. Yeah, I think that's where we stopped. So I think I'm gonna stop here with you guys. So let me make a note. So let me see. Don't get excited though. We're not done. We're not done for the day. I know sometimes when I say stop, students are like, "Oh, bet." I was like, "No, we're not done. We're doing our best to honor the time." So let me see. I'm gonna say like this. We stopped here. Today is what, Tuesday, September 1st. That's not a P. September 1st, 2020. And then double star. And then I'm gonna say start here. Start here. This will be on what, Thursday? Let's see, Thursday. That'll be September 3rd, 2020. Okay. Okay. So let me take a quick moment and let me go ahead and load this so you can access what we wrote. Share. Send it to box. Not the 4 p.m. Right here. This one. This one. Into the notes. Okay. We're gonna send it to box. Once that finishes loading, we should be good to go. Now, while that's working, we're gonna hop over to Pearson. So over here, yes, Pearson. We're already loaded, so I kind of want to start it over. So let me go to manage. And today we're on week 3 right here. I want to copy that assignment. Do I have another version? I want to copy week 3. So that way we can have a fresh one. Select. I just want to copy it. I don't want to assign it though. I just want to save it. Okay, that looks like that loaded. So then what I'm going to do is load a blank page and bring it back. And then that should be at the bottom. I'm going to assume that it worked for right now. And I'm going to go back to the student view. Oh, I didn't load it. So I need to access it over here. And I just want to preview. Shrink this down so it matches the size. Okay, that's fine. Let me shrink this one down some more because we're not really going to be using this one. I'll just put it here for now. Okay, and this is the one we are using. And let's actually come here. Okay. All right. So let's do this. So this is how we kind of did it earlier with the earlier group. So in the chat window, you know how I do the whole random number with Google. I haven't decided to do extra credit points yet. But in the chat, like, go ahead and type whatever. We're going to choose a random number 1 to 21. What number do you think they're going to choose? So in the chat, you can go ahead and start it, right? Just what number do you think is the Google's going to choose? Okay, so we got 14. I'm going to leave it open for 10 seconds, all right? Let me see. 10, 9, 8. Okay, we got a good amount. I think I'm going to just go ahead and close it. 5, 4, 3. Okay, we did the 10 seconds. I'm going to close it out. So it's closed, right? So that's the close. So now, let's see who got it right. Now, I'm not going to necessarily give extra credit. It's just a fun little game, right? Hey, Google, give me a random number 1 through 21. And the winner is
13.
13 is Zaire. Lucky number 13. So he would have got So he was the first one that got it correct. Okay, let's look at number 13. All right, so we're going to go to question number 13. It's just a fun little game, just to shift the energy a little bit. Okay.
So I get extra credit?
We're not doing that just yet. But let's just kind of keep playing. Let's keep going. Okay. So use the vertical line test to determine if the graph is a function. Okay, the first person to type the correct answer. I'm noticing this stuff though. All right, so we have this. Is this graph a function? Does it pass or fail the vertical line test? You got a 50-50 chance. Oh, okay. I was like, even if you just guessed, you got a 50-50 chance, so you could be quick, right? All right. So thus closed. So we already got a first answer. Now I'm gonna say no, right? Because look right here, these two, they fail the vertical line test. They're stacked on top of each other. So they're going to fail the vertical line test. So this is not a function. So we're going to say no. So the person that would have gotten that one, that would have been, I think it was Mr. Malaj would have got. Now, if I were given an extra credit, I would give that one to Mr. Malaj. He was the first one. Let's see. We got that correct. Okay. So now we're going to play our game again. So we did number 13. So let me see. The polls fail was the last one. Let me see. First, I'm going to type. So once you see open, we can start we got to wait for the word open, okay? Right? We're going to open it. Okay, the polls are open. We're going to leave it open for like 10 seconds. 9, 8, 7, 6, 5, 4, 3. Okay, and the polls are closed. Okay. So now, let's go back and see where did we leave off right here. So, okay, let's see what number we get. Are they still coming in? Okay, we're good. Hey Google, give me a random number 1 through 21.
9.
9. Who got 9? Who got 9? Anybody got 9? No. Oh, what? What? What is going on? That's scary. Oh my goodness. Oh, wait a minute. Okay. Okay, that's scary. He got it twice. He got it back to back. Oh my goodness, that's scary. Okay, wait a minute. Wait a minute. What are you doing, Mr. Zaire? How did you get that?
Hey, I got that. You know what I'm saying? Too nice.
His intuition is on point. Okay, let's see what's happening. Okay, so let me get to the close. How is he cheating? He's not cheating. He got it in before I put close, so I know he submitted it before I stopped. Oh, we got shade. We throwing some shade. Okay. All right. So now let's see. I'll do that later. What's the time? Okay, let's look at this number 9. He got it twice. I'm baffled. Let's see if he does it again. I'll be like, okay.
I get extra credit.
We'll see. We'll see. Again, I'm noticing this stuff. Okay, this is question number 9. So it says, find the domain. Okay, in general, for a rational function, we cannot divide by what number again? In general, with fractions, we cannot divide by what number? 0, right? For and more, right? So we can't divide by 0. So what value of x makes the denominator 0? Can someone want to type in the chat the correct answer here? First one, is it A, B, C, or D? Which one is correct? So -5 is correct. So then which answer? What's the answer here? Is it A, B, C, or D? Okay. So I see D. Let me see. Oh, we got a D. We got a C. Let's keep going. Any other takers? C? Oh my goodness, you guys. Okay. Okay. So, oh my goodness. Oh. All right, I'm going to close this out. It took way too long. So close. Okay. I can't believe we vote for C. It's not C. So look. Find the domain, right? So we cannot divide by 0. So basically everything is going to work except for -5. This is only half the story. We need to incorporate all numbers except -5. It should be A. My vote is for A, but it's closed. I don't think I ever saw A. Nobody ever said A. We said D and C, but nobody said A. I'm going to go with it. Let me cross my fingers. Awesome sauce. Okay, so that one was A. So, I mean, again, C was only half the story. It was this half, but you're forgetting about the other side of 5. Okay, stop me if we have any questions. See, the A came after close, so that's too late. Too late. It's all good. All right, let's try again. So,
I got a question.
Go ahead.
So, why did you say it was -infinity to -5 with the brackets? I mean,
parentheses and not the brackets?
Yes, sir.
Okay,
yes, sir.
So from this equation, we're saying everything works except for -5. We had to throw out -5. Remember, the brackets mean we include the -5. Right?
Okay.
We don't want to include -5, so that's why it had to be parentheses.
Okay.
Yeah. Okay, let me see. Okay, so I'm going to type open, and we'll let it be open for 10 seconds. We're just guessing the next random number. And it's open. All right. Watching the clock. 10, 9, 8, 7, 6, 5, 4, 3. Man, we got a good amount. Okay. All right. Let's see if he gets it again. And it's closed. Okay. So where did we open it? I'm going to go back to where we opened, which was, it was flying. I might have to shorten that time period. Okay. So Zaire, he's back to back for 2. Let's see. He is the first. Okay. Hey, Google, give me a random number 1 through 21.
Here's a random number. 2.
2. He didn't get it this time. Wait. Okay, so 15. Let's see.
Bro, I guess 15.
Wait.
I guess 15.
It's 2. It's 2.
Oh, I thought you said 15.
It's 2. Let me see if anybody got it. Everybody's trying to get 15. 12. Nobody got 2. Up. This is Jarvis Squire is the first one to get it right, even if you do multiple attempts. So right now we are doing whatever Zaire says. It doesn't work like that. So Mr. Jarvis Squire got that one. Wait a minute. Where's the close? Oh, no, he didn't get it. That's after the close. After the close. So close. So close. Okay. All right. So let's hop to question number 2. We haven't done this one. Determine the domain and range of the relation. Oh, this is straightforward, right? Okay. And then whether or not it's a function. What's the domain here? So the domain should be the set of inputs. So it should be -2, -1, 0, 1, 2, 3, 0, 1, 2, 3. Don't need that comma. Each answer choice only once. Domain, this looks good. Awesome sauce. And then the range is a set of outputs. Again, typing each answer only once. Use commas to separate. Type each answer only once. So we're going to say 1, 0, 2, -3. Okay, so that was the range. And then, is this a function? Anybody want to guess this one? Is this a function, yay or nay? Do we have any repeating x's? There are no repeating x's, so this should be a function. I'm going to go yes on this one. All right. Okay, that looks good. Okay, it's random number time. Let me see. We're going to shorten this one to 5 seconds. We're going to go open. It's open.
You got the range again? My fault.
Okay, we'll come into it. Give me just a second. 5. It's flying, man. You guys have not played around. Okay, we're going to close it. Close. Okay. So let me go back to open. Okay, there was a question about range. Let me see. The open. You can't do it in multiple goes. Okay, I'm going to let that be. I don't know how I feel about that one. Okay, the range, right? The range was a set of outputs. So the domain was the input, so just the x values, and the range was the y values, and no repeats. So you see how it repeats twice? So we only listed it once. -3 repeated twice, so we only listed it once. Okay. Let me see. Let's go here. What's the time? We're still doing good on time. Hey Google, give me a random number 1 through 21.
Here's a random number. 15.
15. Let's see. None there. You were one question too early, Mrs. Zaire. Let's see. 15. Nope. I don't even know what that word it is. What is that? You got an I? 15. Nobody got 15? Close. Okay. All right. Well, that's okay. No winners. No winners. Okay, cool. Okay. Let's go to question number 15. Let's see what's going on. Real quick. What's the answer? Yes or no? Is this a function? Does it pass or fail the vertical line test? It fails, right? So is it a function? Yes or no? You could just look at that one, and you should just know that one automatically, right? No good. Okay, we can open it back up. Let's go open. We're going to go for 5 seconds. 5, 4, 3, nobody? 2, 1. Let's give it a few more seconds. Okay, and that doesn't work. Close. I wouldn't even if that was right, I wouldn't even accept that one. All right, so it's closed. Let's see, did anybody get this one? I keep thinking about incentives. One day I might come in with some prizes. Okay, let's go here. Because like my favorite instructors, they would have prizes. Like, just if it's not extra credit, it's something. All right. Hey Google, give me a random number 1 through 21.
Here's a random number. 21.
21. Did anybody get that? 17. That doesn't count. No. We should have let it stay open longer. Okay. No winners. Okay. I'm just gonna say nope. Okay. 21. Let's look at question 21. What time is it? Okay, let's see. So it says students have envelopes for extra money. Their initial cost to obtain the information for the job. The initial cost to obtain the information for the job was $260. Each envelope costs. Wait, student stuff envelopes for extra money. Their initial cost to obtain the information for the job was $260. Each envelope costs 5 cents, and they get paid 7 cents per envelope stuffed. Let X represent the number of envelopes stuffed. Express the cost as a function of X. Express the revenue as a function of X, and determine analytically the value of X for which the revenue equals the cost. So the students are stuffing envelopes. The initial cost, so for them to get this information, they paid $260. So there's a net fee. Okay, we need to write this down. So I'm going to take some notes, and I'll show you my notes momentarily. Okay. So we have a cost function. So for part A, this is, let me see, this is homework for week 3 from section 1.3 functions. Okay. This is question number 21. And from the book, it comes from section 1.3, question 63. Okay, so for part A, we're developing a cost function. Now we have for them to get this information, they paid $260. So just to play the game, they paid $260. It says each envelope costs 5 cents. So we're going to say the 5 cents times each envelope. And then they get paid 7 cents, okay? So I think I got my cost function. I'm going to let that be. And then it says express the revenue, right? So for part B, I know you can't see it just yet. But the revenue, the money generated. So they get paid 7 cents for each envelope. I'm not liking how these numbers are working out so far. They get paid 7 cents for each envelope stuffed. Okay, does anybody have a cost function that they'd like to share? You can just read it out loud or type it into the chat. Anybody have a cost function? I gotta go see if somebody's cooking because
I got one.
What cost function did you get or revenue function?
So I have 0.05 x plus 260.
I got the same thing. Let's try that. Who said that?
Dalen Land said that.
Williams? Is it Williams?
No, Dalen Land. Dalen Land right here.
Land. I got you.
Yes,
okay.
sir.
Let me see. So 0.05x plus 260. Let's see. How do we do? Awesome. Okay. Can you tell me the revenue?
The revenue?
Yeah.
That would be 0.07, right?
0.07.
Shoot. It'd just be 0.07x or something.
Yeah, X, right? Because that's the money generated for each envelope we stuff, right? So like if we stuff 1, we gain 7 cents. If we stuff 2, it'll be 14 cents, right? That should be it.
Okay.
Okay. So this looks good. So then the revenue equals the cost. Okay. Anybody got an answer here for part C? So when will the first one equal? At what value of X will the first one equal the second one? Anybody got an answer there? All right, let me see the time. I'll leave this one open for 5 minutes. And the first person that can correctly give me the answer, you can either type it in the chat or you do the audio, whichever one comes first. What value of X makes this true? Where do I used to do it there. I need to be able to make notes.
Wouldn't you just plug in? Let me see.
Hey Siri, start a timer for 5 minutes.
Okay, 5 minutes and counting.
Hey Siri, play the Jeopardy theme song.
Playing Jeopardy main theme by Dominic Hauser.
You got 5 minutes. Let me see how long is this song. This song is a minute. We're not about to listen to this song for 5 minutes. I'm gonna play it a little bit softer though, so you can think. But I do want you to take some time to see if you can answer this one. Because whoever does the most talking does the most learning. If I'm doing all the talking, I'm going to do all the learning. So I'm trying to find some ways to pass it on to you guys. Really, with this experience, it gets to a point where you start teaching yourself. You can actually teach yourself most of this. And then when you get stuck, that's when you either want to link up with somebody or talk to, connect with your professor or link up with a tutor. But you want to go as far as you can on your own. And then eventually, you'll be able to teach yourself most of it. And that's really, that's how I learned. My professors were there just to kind of help me not be stuck too long. Let me try this a few more times. You got an answer? All right.
Hey, I got an answer.
Who is this?
Mr. Land.
Mr. Land. Okay. Let's quiet this. What answer did you get? Mr. Land.
Oh.
What color you feel? Give me a color, Mr. Land.
Wait, hold on.
No answer? No?
No answer.
Oh.
Okay.
Anybody else?
I think I got it.
Okay, Mrs. Zaire, what color you feeling?
You said what color?
Yeah, what color?
Blue.
Mrs. Zaire.
Green.
Green, okay. Light green or dark green?
Dark.
Okay, let's do dark green. So I'm going to just call you a Z for now. What's your answer? What answer did you get?
So I just divided 260 by 0.07. I got 3,714.
You gotta stuff 3,000 envelopes to break even?
Yeah.
I hope not. Oh my goodness, I hope we don't have to do that many. Oh, the time is still going. Okay.
I got one. I got a number.
Okay, who is this?
Dayland again.
Mr. Lane, what color are you feeling?
I'm feeling red.
Red. I felt it coming. I could feel it. I was like, I could feel the energy. Red is a power color. Let's go. I got
1,352.
1352. You want to tell me what you did to get that?
Yes, sir. So I did 0.02 times 260. I got the 5.2, and then I did 260 times 5.2. It's wrong.
Okay, let me try one more. I don't know how I feel about that one. Let's try one more, and then
all right.
I'm not saying it's wrong.
Okay.
Because I haven't worked it out yet. I wanted you all to look at it first. Mr. Rabate, you have an answer. You can type it in the chat or just come on the audio.
Yeah, I got it.
Mr. Rabate, wait, Mr. Rabate, what color you feeling?
Green.
Which color, light or dark?
Dark.
Dark green. Okay, Rabate. All right, let's see. So this is gonna be the last one, Rabate, and then we'll walk through it. Mr. Rabate, what result did you get?
13,000.
13,000. What? Even?
Yeah.
13,000. How did you get that number? What did you do?
I just set up an algebraic equation. Put 0.05 plus 260 equal to the 0.07x.
Okay, and then what did you do next? Okay, so let's look at. Okay, so I'm gonna go with this one. So that's what I would have done, right? You definitely want to practice going with your first mind, because if you always practice going second guessing yourself, then what's going to happen is you're going to start to second guess yourself out of the correct answer. So initially, when you practice going with your first mind. Initially, it might not be right, but the more you practice going with your first mind, the more accurate it'll become, and then that way you won't second guess yourself out of the right answer. So let's see this in action, right? So now we have the cost function, we have the revenue function. I'm going to put my money on Mr. Rabate. I'm going to write mine out. So he said, okay, the question asks, when will the cost be equal to the revenue? So in other words, our cost function being this 0.05x plus 260, when will that be equal to 0.07x, right? So we set the cost equal to the revenue. That purple is awfully bright. I think I'm going to switch that to black. Yeah, I think I'm going to just do it in black for now. Okay, so then if we solve, we can subtract. I'm going to do it a little differently. Now, I'm a fan of clearing out the decimals, right? We can clear the decimals by multiplying both sides by the appropriate power of 10. Now, this might be a little bit extra, but I just want you to be aware of this technique, right? So if we said, let me get a copy of this because I already know I'm going to need it again. So if we said the appropriate power of 10 here to clear out our decimals, we can multiply both sides by the same non-zero. So I'm going to multiply both sides in this case by 100. And I'm going to distribute the 100. This side also by 100, right? So if we do this, it should clear out our fractions. So then we should get 5x plus the 260 with 2 more zeros. And then on the right-hand side, we get 7x. Okay, we subtract the 5x from both sides. Now, you don't have to do this. I'm just showing you that this is a technique that we have at our disposal. Bring down the equal symbol. We get 26,000. Thank you. 26,000. And that's a 2x. And then divide both sides by 2. Okay, that's that 13,000. So I think we were close before, but I felt like I could see that something was a little off, but I knew we were on to something, right? We divide both sides by 2, x equals 13,000. Okay. So we got this result. So this is saying, I mean, yeah, I think we got something like that earlier too, didn't we, Mr. Zaire? You had something close? You had something close, but I think you had some other numbers in there.
Yeah, so, I don't know how I got my number.
It's okay. So we got this, right? And let me go like this to remove this. Okay. So for part C, and let me label it. Right, we started part C here. What's the time? Okay. So again, we took our cost function and we can highlight like this. We took our cost function and set it equal to the revenue function. We plugged in those equations and then we solved it. Now, I use a technique of clearing out the decimals. So I multiplied both sides by 100 and distributed. This times 100 was this. This times 100, I added on 2 more zeros. And this times 100, we got 7. Subtract. Is this my family? Let me see. Did somebody click on my? I don't think so. Okay, let me wrap up because we're closing out. We're almost done. I mean, you saw the evolution. So let's try this 13,000 and see what happens. Let's see if it works. We are here, and so according to this, it looks like we got to stuff 13,000 envelopes just to break even. That's a lot, just to break even. So anything above 13,000 would be profit. Is there another question? Yeah, that was it for that one. Okay, notice how even though we finished the question, we could click similar question, or if we just didn't know what to do, we could click question help. I'm a fan of view an example. We also have the e-textbook here. We have a full version of the book. And if none of those work, you can click on the Ask My Instructor. And what that'll do is it'll send me a screenshot of the question you're working on. And I'll get to it as soon as I can. I know I'm totally behind on my emails. So that's why I'm trying to take time in class now to kind of address email questions. Since I can't go through manually. Oh, I didn't mean to click on textbook. I wanted to click on the view an example. So if we view an example, we'll get the exact same questions with different numbers. And then they'll walk us through step by step. And then we can take that and apply it to the one that we're working on. Right? But you have an explanation of what's going on. This is why I really, really vouch for Pearson because of this tool. Okay? All right, so I'm actually going to end the session here. Keep in mind that we're still streaming. Are there any questions that people don't mind going out on the stream? Let me do like this. Let me do like this. Give me just a moment. Let me switch this back like this. Okay. So are there any questions that anybody doesn't mind asking that goes out on YouTube?
I got a question. I know you're behind on the emails.
So yeah,
will you catch up tonight?
Well, can you? I can stop the stream. Do you need me to stop the YouTube stream to ask your question?
Oh no, I'm cool. I was just asking.
Can you ask me now? Like either you can pull it up or just ask the question.
It was just about how I'm Central Time and you got it in Pearson where it's set up is Eastern Time.
Mm-hmm.
Yeah, yes sir. So I get an hour less than assignments, and then if I live on the West Coast, that's 2 hours less. That's not fair. You know what I mean?
Yeah, you just got to factor that in. That's one of the things with online. You just gotta.
Cause think about it. If you had an 8 o'clock class and I was on the West Coast, I gotta wake up at 5 o'clock just to get to my 8 o'clock.
Yep.
You know what I mean?
Yep.
Just,
but because I'm not gonna go through and like
cents.
So the way I address that thing, because I know certain people, it seems like you have like a few hours less. You just have to kind of wake up earlier. But so like what I did to address that, honestly, we get unlimited attempts at all of our assignments, and then even if it's late, it's only a 10% late penalty. Right? It's only 10%.
So it don't go below 10%.
I'm not gonna do more than the 10% late penalty.
You know what I mean? Like one day is 10%, then the next day
No.
it's 80%,
It's just a one-time flat 10%. So what that
Okay.
means is like even if it's late, you can still earn a
I can
90.
still get an 8.
You can still get an A or a 90 if you want, right? That's exactly what it is. And I've had students do that. Like I've had students just pretty much submitted everything at the end. I saw it. I was like, okay, that's all I need. So I used it, and they were good to go. Yep.
Yes, sir.
But I think I like that point. That's a very valid point. The demon time. We're not gonna do demons. Let me see. Okay, let me try this one. Hey Google, change the light color to purple. So like what I'll do. Oh, that's intense. Oh my god. Even here, like my eyes. So what I'll do is though, periodically I'll choose like a color and I'll meditate. I'll do a light bath and I'll put on like a guided meditation for that chakra. So I do all that kind of stuff. You see my crystals.
Yeah,
I'll do chakra meditations, and so and periodically I'll put on different colors. And it has like you can do like strobes, and it'll like flow through different colors and things like that too. But I haven't figured that out for Google, but there is a way to get that done too. Hey Google, change the light color to white. Okay. All right, guys. I didn't really want to keep you much longer. If there aren't any other questions, I'm gonna let everyone go. Okay. All right. It was fun. I hope you had some fun. Hope you learned something, guys. It was great. You guys are awesome. And we will be back same place, same time on Thursday. I think class starts at 5:15. Okay. Maybe if I do my timing right, I'll get in early and I'll do a little bit of gaming. If you want a game with me, that game is Mobile Legends. Okay. So I'm doing a little bit of marketing for them, but yeah, that was Mobile Legends. So yeah. Okay, guys.
Or something.
Okay, guys. I'll see you next time. Yep.
Appreciate it.
Yep. Take care. Let me just hide it. That'll be easier. I want to hide that too. And then right here, it's still in the way.